Quality management is built on 7 key principles: customer focus, strong leadership, people engagement, a process-driven approach, continuous improvement, evidence-based decision-making, and effective relationship management. These principles ensure we not only meet requirements but continually exceed expectations. At the process level, we move through 3 main steps. First, we plan for quality. Then, we perform quality assurance to make sure our processes are effective. And finally, we perform quality control to verify that the deliverables actually meet the required standards. It's a continuous flow that drives both performance and customer satisfaction. Managing quality is all about using the right inputs, applying proven tools and techniques, and delivering meaningful outputs. We start by pulling in key documents like the quality management plan, lessons learned, and risk reports, along with leveraging organizational process assets. We then apply a variety of tools, from data gathering and analysis to audits, problem solving, and quality improvement methods. This allows us to produce critical outputs like quality reports, change requests, and updates to project plans, ensuring we deliver consistent, high-value results throughout the project lifecycle. In the quality assurance process, we start by gathering critical inputs like the project management plan, quality metrics, work performance information, and quality control measurements. These provide the foundation for evaluating and improving project processes. We then apply key techniques like quality audits, process analysis, and continuous improvement methods. This helps drive essential outputs such as organizational process asset updates, change requests, and updates to both the project management plan and project documents, all ensuring that quality is built into every stage of the project. The cost of quality is the total cost of ensuring that a product or service meets quality standards. It's divided into 2 main categories: the cost of conformance and the cost of non-conformance. The cost of conformance covers things like prevention and appraisal, essentially the money we spend to avoid failures, such as training, inspections, and process documentation. On the other hand, the cost of non-conformance is the money we spend because of failures, like rework, warranty claims, or even lost customers. Investing upfront in quality processes typically costs far less than dealing with the fallout from defects later. A quality audit is a structured review to ensure that project activities comply with organizational and project policies, processes, and procedures. It's not about blaming individuals, but about identifying areas of improvement and best practices that can be shared across the organization. The benefits of conducting quality audits include improving processes, reducing costs, increasing customer satisfaction, and ultimately enhancing product quality. A successful audit can lead to recommendations, corrective actions, or process improvements that make a real difference in project outcomes. Control quality tools help us measure, monitor, and improve project deliverables. Some key tools include control charts, which show process variability over time, and Pareto charts, which help us prioritize the biggest sources of problems based on the 80-20 rule. These tools give us insights into where to focus our improvement efforts most effectively. Statistical sampling is another useful method where we inspect a subset of deliverables rather than checking everything, saving time and resources. Following a statistical sampling process ensures that the samples are truly representative, making our quality control efforts efficient and reliable. Statistical sampling helps us manage quality control by analyzing a smaller, representative subset of outputs instead of inspecting every item. Attribute sampling checks if outputs meet a yes or no standard, while variable sampling measures how much outputs vary within a range. By applying these sampling methods at different stages, incoming, in process, and final, we catch problems early and save time and resources. The goal is to spot trends, take corrective actions, and reduce defects over time. With a smart sampling strategy, quality improves without overwhelming the team with inspections, leading to better products and more efficient processes. Sampling is the process of selecting a smaller group from a larger population to draw conclusions about the whole. We start with the full population, define a sampling frame, and then choose a sample to study. This method saves time and resources while still providing reliable insights. When we repeat sampling many times, the distribution of the sample averages forms what's called the sampling distribution. Understanding this concept helps us predict how much our sample results are likely to vary from the true population values. It's a powerful tool for decision-making in quality control and beyond. Here we see how statistical sampling data supports quality analysis. Sampling allows us to gather focused insights without needing to measure everything. By tracking trends like defect yield, schedule variation, and defect density, teams can make data-driven decisions. This approach helps in identifying issues early, improving processes, and ultimately reducing defects and variation, leading to better quality outcomes without excessive testing or inspection. When assessing compliance risks, we follow 4 key steps. First, we connect potential risks to affected parties and possible outcomes. Then, we prioritize the most serious risks and identify the controls needed. Next, we implement and validate these controls. Finally, we continually monitor, evaluate, and update controls to stay ahead of emerging risks. This cycle helps maintain strong, proactive compliance across the organization. When assessing technology services, 4 main considerations come into play. First, availability, ensuring systems are accessible when needed. Second, capacity, verifying the system can handle current and future demands. Third, continuity, making sure we have robust plans for disruptions. And finally, security, safeguarding data and operations from potential threats. Together, these factors help build a resilient and efficient infrastructure. The project manager is solely accountable for ensuring all deliverables meet stringent compliance and quality requirements, securing formal sign-offs from authorized stakeholders. This process is not a mere formality, it is a critical control mechanism that validates alignment with scope, standards, and expectations, transforming completed work into accepted value. Proactive quality sign-offs serve as an early warning system, exposing variances and compliance threats before they escalate. By rigorously managing approvals, the project manager safeguards the timeline, prevents budget overruns, and mitigates risks, ensuring that every deliverable not only satisfies immediate requirements but also upholds the project's broader strategic and regulatory obligations. This disciplined approach turns quality assurance into a strategic advantage. Effective risk and compliance management demands a structured approach that anticipates potential disruptions and proactively addresses vulnerabilities. By connecting risks to affected parties and potential outcomes, organizations can prioritize the most serious threats and determine the appropriate controls. Implementing and validating these controls ensures not only compliance but also builds resilience across systems. Continual review, evaluation, and updating of risks and controls further strengthens an organization's ability to adapt to new challenges, maintaining both operational integrity and regulatory alignment. In parallel, the availability, capacity, continuity, and security of services must be considered foundational pillars. A clear escalation model, such as the tiered approach to ticket resolution, ensures that issues are efficiently addressed according to their complexity and urgency. From Tier 0 self-service solutions to Tier 4 third-party interventions, this structured escalation path maximizes response effectiveness while maintaining service reliability. By intertwining robust risk assessment with thoughtful service management, organizations can achieve a balanced, high-performing environment that supports both compliance obligations and customer satisfaction. The effectiveness of any governance, risk, and compliance program is deeply rooted in the quality of its audit processes. At its core, audit quality hinges on the seamless interaction between inputs, processes, and outputs, all influenced by a broader ecosystem of management, governance bodies, regulators, and users. A robust audit system depends on contextual factors like corporate governance frameworks, regulatory compliance, and information systems integration. By maintaining strong, transparent feedback loops among all stakeholders, management, auditors, and governance boards, organizations not only uphold compliance but also foster a culture of accountability, operational excellence, and continuous improvement. Moreover, these interconnected systems emphasize that audit quality is not an isolated achievement but a shared responsibility across the organization and its environment. External pressures such as litigation risks, financial reporting regulations, and broader cultural expectations shape how audits are performed and perceived. High-performing teams recognize that by investing in strong inputs, like competent staff, ethical standards, and efficient systems, they optimize the audit process, leading to outputs that satisfy both regulatory demands and stakeholder expectations. Thus, a strategic, context-aware approach to audit and assurance becomes indispensable for sustaining trust and driving long-term organizational value. Quality control is the process of inspecting and verifying that a product or service meets specified quality standards. It involves activities such as testing, measuring, and reviewing outputs to detect defects or deviations from requirements. QC focuses on identifying and correcting problems after they occur, ensuring that deliverables are consistent, functional, and meet customer expectations. Typical tools for quality control include inspections, checklists, and statistical process control charts. While quality assurance and QC are often related, they serve different purposes. QA is a proactive process that focuses on improving and designing processes to prevent defects, while QC is a reactive process that identifies and fixes defects in finished products. In a complete quality management system, both QA and QC work together to achieve high product reliability and customer satisfaction. QA builds the framework to minimize errors, and QC ensures the final outputs are error-free. Quality control stands as a critical checkpoint in ensuring project success, acting as the bridge between well-conceived plans and verified deliverables. The structured approach of integrating inputs, such as the project management plan, quality metrics, and organizational assets, through rigorous tools and techniques like data analysis, inspection, and statistical sampling guarantees that the outputs meet or exceed expectations. Controlling quality isn't just about defect detection. It's about embedding a culture of continuous improvement, where lessons learned and performance data feed back into refining project execution and strategic alignment. By emphasizing both process and accountability, organizations can proactively manage risks, improve stakeholder confidence, and drive higher efficiency. As illustrated, quality control doesn't exist in a silo. It operates within a broader ecosystem involving change management, environmental factors, and enterprise-wide documentation. Successful teams don't simply react to quality issues, they anticipate them by systematically gathering insights and updating critical project documents, creating a cycle of improvement that strengthens future initiatives. In doing so, they build a sustainable foundation for excellence, where verified deliverables not only meet technical specifications but also strategic business goals. Effective quality management in projects hinges on the seamless interaction between planning, assurance, and control. Inputs such as project management plans, quality metrics, and approved change requests flow into a disciplined process utilizing a variety of analytical tools and techniques, including cause-and-effect diagrams, flowcharts, statistical sampling, and inspections. This structured approach ensures that quality is not left to chance but is systematically embedded within every project deliverable. Quality control, positioned as the final checkpoint, validates both the deliverables and the changes, ensuring outputs align not only with technical specifications but also with evolving organizational needs and expectations. Moreover, robust quality control processes lead to a cycle of continuous improvement by generating critical outputs like updated project management plans, change requests, and organizational process asset enhancements. These outputs feed directly back into future project planning, creating a self-reinforcing mechanism that drives higher standards of performance over time. When organizations prioritize a strong quality control culture, supported by proactive inspections, data-driven decisions, and effective change management, they build resilience, enhance stakeholder trust, and position themselves for sustained success in increasingly competitive environments. Within the broader framework of project quality management, inspections play a critical role in verifying that deliverables meet specified requirements. As a vital tool within the control quality process, inspections involve detailed examinations of work results, products, or services to confirm compliance with established standards and project objectives. They not only validate the correctness of outputs but also uncover any deviations or deficiencies early, enabling timely corrective actions before small issues escalate into costly problems. By integrating inspections into the quality control cycle, organizations create a feedback loop that strengthens both project execution and future planning. Effective inspections contribute to key outputs such as verified deliverables, work performance information, and change requests, all of which drive continual improvement and foster a culture of accountability. Whether through peer reviews, audits, walkthroughs, or formal testing, inspections serve as both a safeguard and a catalyst for delivering consistent, high-quality project outcomes. The DMAIC framework complements project quality management by offering a structured approach to problem-solving and continuous improvement. In the plan quality phase, the define and measure stages of DMAIC help identify customer requirements and gather baseline data on current processes. During quality assurance, analyze and improve drive root cause analysis, waste elimination, and solution development to refine processes before defects occur. Finally, quality control aligns with the control phase of DMAIC, ensuring that improvements are maintained, processes are monitored, and validated deliverables meet all requirements. Integrating DMAIC principles strengthens the overall focus on process excellence, risk reduction, and customer satisfaction across projects. The integration of project quality management, the DMAIC methodology, and the CMMI maturity model provides a comprehensive framework for achieving and sustaining high levels of performance excellence. Project quality management ensures that quality is planned, assured, and controlled throughout the project lifecycle, while DMAIC offers a structured, data-driven approach to problem-solving and continuous improvement. Each phase of DMAIC, define, measure, analyze, improve, and control, aligns seamlessly with quality management activities, supporting a disciplined way to meet project objectives. When DMAIC principles are incorporated into project quality processes, organizations can systematically identify inefficiencies, address root causes, and enhance the value delivered to stakeholders. CMMI maturity levels further strengthen this structure by embedding best practices at an organizational level, evolving from unpredictable and reactive processes, Level 1. Initial, to fully optimized and continuously improving systems. As an organization matures through the CMMI levels, its ability to plan quality, execute improvements, and sustain gains becomes increasingly sophisticated and reliable. Together, these frameworks create a powerful synergy. Project quality management defines what must be achieved, DMAIC prescribes how it should be improved, and CMMI ensures that the processes to achieve and sustain success are deeply institutionalized. This integrated approach not only enhances project outcomes but drives enduring operational excellence across the enterprise. Thank you for your unwavering commitment to excellence and your dedication to mastering the profession. We wish you resounding success on your path to certification.